This is going to be largely just on the Synapse Serverless database. How to use it, why we would want to use it, where you can use it, these kind of things, some of the best practices and some limitations that you really should be aware of with these types of things. So first, who am I? My name is Jarid McKenzie. I'm the partner lead analytics architect over here at Iteration Insights. I've been doing this kind of stuff for 9-10 years. Looks like I've lost weight since that picture was taken, so that's always good. And I've been teaching BI and analytics for more than 5 years. I taught back at the University of Calgary for a while in their continuing ed program, and I've done a bunch of work up with SAIT, the Southern Alberta Institute of Technology, with their BI Fast Track program. So we are talking about Synapse Serverless today. So I've got 8 different things that we're going to go over. So setting things up, how do we query files, some of the best practices that you really should do whenever you're setting up any sort of reoccurring process. And at the end, I'm definitely going to go over some of the limitations and best practices that I highly recommend that you go over yourselves. To start things off, I want to start with a very big, bold, red letters, stars and fireworks going all over the place of what you should be using Serverless SQL for, and that is only querying data. Whether that is, you can create your own tables to save some results, which we'll go over, but Serverless is not able to manage records. So you can't insert records into a table, you can't update data, you can't delete data. All you can do is define records. You can define things on top of files, and you can actually write to files, but once it's written, you can't update things. So limitations. So big things is that you should only be using this to query data, and make your results usable for other purposes. So whether you want to use it in something like Power BI or ML applications, or any other sort of analysis type of operation, that's what you want to be using Serverless SQL for. Now, some of the things I have done in the past is use it as a querying step to move data down the stages of my Delta Lake. So going from the bronze or raw layer, creating some sort of view on top of my data, and then pushing it into a gold or curated layer where it can be queried from a source like Power BI. You can use it in that fashion, although what I was doing was overwriting my gold table all the time, and it was a relatively small use case, so it was perfectly fine. But if you need to update and manage your transactions, use the Delta Lake. Actually, I was going to point out that blog that was called out earlier anyway, so that's excellent. You guys already have the link to that in the chat. It is a really good primer on how the Delta Lake works. So if you're going to use that kind of thing, Apache Spark, Delta Lake, really good tool. That's really all. Oh, go ahead.
Sorry, just a quick interruption, Jared. Not too sure if you saw in the chat, but we did get a question about implementing a data warehouse by using Synapse Serverless pools similar to BigQuery.
Yes. So you definitely can. We will get into something like that. The big thing that I would probably do with a serverless pool is what you're doing within serverless is you're really just putting metadata on top of your data lake. So all you have all these files running underneath the covers, and then the serverless is just able to query those files. It's not like you're creating SQL tables that physically exist and monitoring what sort of transactions take place on top of that data. Serverless SQL is completely different from dedicated SQL pools because dedicated SQL pools are a massively parallel processing environment where you essentially take a SQL server that has all of the transaction management and it shards over 60 different nodes-ish. Then you can configure things out from there. But when you have the dedicated SQL pool, then you have access to all of those transaction layers. So if you need to have a data warehouse and you need to manage the changes over time, using a dedicated SQL pool is perfectly fine to do that sort of thing. If you're just doing transformations or and data pipelines, Apache Spark is probably a better way to go with that, depending on the types of tools and experience that your user base has. Hopefully that answers some of that question. Omer, shoot me a message if you want to talk further about that. I can go on for a long time about dedicated SQL pools and that kind of stuff. All right. What I've got up here, let's just show the home page. I've already provisioned a Synapse environment. I don't want to go over all of that kind of stuff. The big things that we've got in here is I have a Synapse workspace down here. I've got a storage account that was provisioned at the same time, and then I provisioned a Spark pool. We're not going to go into the Spark pool today. I don't think we probably won't have enough time. The homepage of the Synapse Analytics looks like this. Once you're in there, you've got a bunch of stuff available to you. You have access to pipelines for moving data around and orchestrating data integration. So if you're connecting to multiple systems or you're moving data from its source system to do analysis, you can use pipelines to do that sort of thing. But that's I've written a very basic one just to load data up into my my data lake here. So when you create a data lake, the file system essentially gets provisioned for you. And what's really nice is Synapse and the data lake are married to one another. They talk to each other almost inherently. You do have to make sure you manage permissions reasonably carefully, but that's not that difficult to do. What I want to talk about is how do we actually look at data that's in here. So I've pushed in data from wide world importers just on a daily basis, all the sales orders that gets pushed in here, because I want to show that when you have data that's partitioned on, say, a daily basis, this is a pretty standard use case for a lot of data warehousing needs, and it's very similar to even IoT operations. So if you have some sort of device that's pushing data into a data lake, you can actually attach that to Synapse and query your IoT data very natively. So by default, one of the easy things that you can do in here is actually query these Parquet files. There's lots of different types of files that you can query and write natively. Parquet, in my opinion, is one of the best. The other one would be Delta files. You can have CSVs and JSON ORC format, but a lot of those don't have the same types of compression. And then JSON files has a tendency to be slow to query the first time. So it's really useful for integrating into some other format and then doing your actual analytical queries afterwards. So all I did there was I right-clicked on one of my files. I'm just clicking on January 1st, 2018. I clicked new SQL script, select top, that 100 rows. This is pretty standard. It's usually the first thing that most people do when they get into an environment like this. You can see that we've actually got some results coming back there. All of our order IDs. Like I said, this is just wide world importers data that I've generated, and I've taken the orders and the order line tables and just smushed them together, just so that we've got lots of data to start playing around with. So you can query your files like this perfectly fine. Synapse has access to the data lake. And because I created this, I have access to the data lake too. But if you have other users, you're going to need to start managing how people connect to the data lake in various ways. So while this is excellent, it's really just a starting point where you should go. You'll also notice that we don't actually have any sort of metadata on top of this. All we've done is we're saying open row set, we're getting information from a Parquet file, and what Parquet file are we getting from? This is just selecting all the rows or all the columns from that file. It's pretty basic in that way, and it doesn't manage a lot of things that we should manage in an analytical environment. So first thing you need to do is you need to start creating a database. So what I'm going to do here is the normal database operations of creating a database. I'm going to create one here called AAUG demo for our Azure Analytics user group demo. That'll create that in there. And now I've actually got a database where I can keep all of these assets together. So that's tables, views, procedures, whatever. You have access to almost everything that you do within a regular SQL server, except updating, inserting, and deleting data. So once we've done that, we've created our database. We can go in and actually start using that database. It does not appear up here, so I just make sure to hit my refresh button. You can also connect to this serverless instance with any of the other tools that you've used. I can use SSMS. I believe you can use the Azure Data Explorer, although it's been a while since I've actually used that. And I don't know if I've used it on a serverless instance. So you can test that one for yourself. I'll leave that to an exercise for the listener here. So I've refreshed my data there. Now I can actually start using this data. Let's just comment that out. I don't need to see that right now. Anytime you provision a database, you do need to set up a couple of different things for just the initial setup. What those are is we need to encrypt the database or the credentials that the database uses. Just anytime you're referring to external data, the serverless instance requires that. So what that looks like is just setting up a master key. A lot of this stuff is in the documentation from Microsoft. It's actually really good. There's some quick starters in there and tutorials that walk through all of this stuff. So it's definitely in there. So it's just setup steps. This is what creating a master key looks like. I'm not going to execute this on this screen because I definitely don't recommend people execute master keys on a stream that is recorded. So even though I'm going to delete this right afterwards, I don't recommend people try copying that password and use it. Make sure it's a really strong password. Make sure you save it somewhere that you can refer to later. So I've just done that on a different screen right now. That's a password in there. You can actually start creating scope credentials. So you can either have an entire server scope credentials, so which basically means that this server can talk to this other thing using some sort of mechanism. So whether that's a password, whether that's an SAS token on your data lake, whether that is the API key on the data lake, you can kind of go in to your storage accounts and find access keys in there. Again, I'm not going to show access keys on stream, but you can access them in that way as well. My preferred method for connecting with the data lake, especially the data lake that is connected to the Synapse workspace, is to use the managed identity. I don't believe the documentation goes into this use case specifically on their tutorials or quick starts, but this is definitely one that I would recommend for you guys to use. What would happen here is anybody who is able to use this identity essentially is impersonating the workspace. So Synapse Workspace can talk to the storage account and query the data on top of that. I don't have to worry about the user themselves having access to the underlying data lake. So there's some benefits to that, and you can secure the serverless database in various ways afterwards as well. So using scope credential with the managed identity is a really, really good mechanism to use. So I'm going to run that script as well. The last thing that I'm going to do right now is actually talk about where the data source is. I have to tell my serverless instance that I have an external data source that I'm going to connect to. It's very, very similar to what's actually up here in this row set code. What we want to do is tell the system that I'm using the HTTPS protocol. I believe you can use the ABFSS protocol as well. There's a bunch of different mechanisms to actually connect to various data lakes. The ABFSS is probably one of the better ones, but because I don't have that written down, I'm just going to use the one that I've got in here. Setting up data sources as well, it allows you to scope the locations that data source has access to. For example, I'm just going to go quickly back to my data lake for a moment here. And if I go to the very, very top level, you can see I have two folders right now. I've got raw, which is where my raw data is, and I've got Synapse. This is just where some of the Synapse assets get created. So my Spark pool built some stuff and toss it into this folder. When I will query external files, it's going to put some metadata into this folder. If I don't want it to have access to this Synapse instance, I can allow myself to have access to just scoped folders as well. So if you have, say, analysts that you want to provision access to just the curated folder, if you've built a data warehouse on top of the data lake, using credentials and data sources in that way, it goes a long way to securing the data. So let's take a look here. We've already created our scope credential. Now we need to use that scope credentials to connect to something. So you can see what I've got here. This is just the first part of this instance of the storage account. So I'm referring to storage account and the file system within the storage account. The rest of this is the file path. So there's some folders. I've got some file back here, but the data source, I can refer to a top level folder for me. So you can see the data source, I give it a name, I give it a location that it has access to, and then the credential that it uses to access that spot. So this is using the managed identity. It's a credential impersonation that's taking place here. I'm going to execute that. I know I've done a bunch of stuff and not actually gone over anything. I'm not really showing anything other than the automatic script that gets written up here. So let's actually see what it looks like to write this script using the credentials and using the data sources that I've just created here. If I want to query a file on this database, on this serverless database, I have to use that data source, and we'll do something very, very similar to what we've got there. And you'll see data source, it's enclosed within single quotes. It's given the same name as the data source that I created. And you'll see up here in this bulk operation, this is the relative path to the file that I want to query. And then lastly, I give it the file format. There's a bunch of different file formats that you can connect with: Parquet, Delta, Org, JSON, CSV. There's a bunch of them up there. Anyways, in this instance, it looks like just because I was doing this a little earlier, if I want to query the exact same data using those credentials, there we go. Now we've got access to this. So that's querying data. Very, very simple. We're using one of our databases that we've created, and I've got access to that information. Quick side note is that when you query this, you only get the inferred data types. Right now, basically, serverless doesn't know what my data types are, other than just reading some data and just saying, okay, this is going to be an integer. This is going to be a date time. That's going to be a variable character. When we get to some of these things, like I've got a description in here, one of the big problems is that the inferred data types are the maximum of those data types, and it does tend to slow down queries sometimes. So you got to be cognizant of that. In order to show that, there is a stored procedure within serverless here called SP describe first result set. I'm just going to copy and paste that so I don't have to retype everything out. Basically, you just give it the query that you want to write or that you want to execute, and it'll give you some information about this query. So if I run this, what you'll see is that my results are, what are my column names? What's the order of those columns in? What are the data types? Is it nullable? So it gives lots of information about these columns. And right down here, if I just zoom in on this column right here, you'll see that the system data type is varchar 8000. That's a big data type. It uses a lot of space, or it could use a lot of space, and it does make your query a little less efficient, especially if you're querying over very, very large files. So in order to make sure that you actually provide specific data types to each of these columns, you do have to use the with statement. So what that looks like up here is a little suffix on the end of my row set option to say, I've got this column and it's this data type. If I execute this, it's just going to give me a single row, because as soon as you start using the with option, it only gives you the rows or the columns that you've described in there. So if I could give it a bunch of my other ones, but you probably saw I've got lots of them in there, so I don't want to type them out and spend all of our time doing that. What has happened here, though, is it has given me a 25 character column rather than an 8,000 character column. I'll prove that by just running this exact same thing with that stored procedures that I showed beforehand. If I run that, I'm going to get a single value here. You'll see varchar 25. I've imposed that specific data type on it. So this will be more efficient if you're writing these things in a repeatable, sustainable way. You're going to want to make sure you describe each of the columns with their specific data types and information about those columns, rather than using the inferred data types that exist on there. All right. Some nice things that we can do is instead of just looking at our row set, or if our file here. So this is just that file. It's a relatively simple or similar to all of the existing SQL that folks may be familiar with. We can do same kind of filtering and aggregations that you guys might be very, very familiar with. You can see in here, I've got a customer ID. I've got a bunch of unit prices and quantities. So if I, instead of just querying everything in there, I did something along the lines of, I want to find out what the actual sale price of each of my customers is. I can look at that in here. I can group by that customer ID. I've got access to multiplying and summing and aggregating by various amounts. Looks like I'm just doing this on a different file. Doesn't really matter. One of the things that you can do in here, though, is you can actually start charting out your data. So this is, it's cool. The issue that I run into here is that all of this data is I don't have any way of manipulating this data. I can't aggregate this in any way. I can't manipulate these charts very much. You can do some stuff. So I would really only use these charts as a basic data exploration tool. Use a single thing to group by, maybe use some other aggregations, but there are limitations here. So I just want to make sure to call that out and let you guys know about that is definitely the case. But it is a very useful feature for doing that exploration. Once you've got this kind of information anyways, you're probably going to want to put it into a proper analytics visualization tool like Power BI, or start visualizing it using notebooks and NumPy or NumPy in Apache Spark, and using the data in other ways. I find these charts not as dynamic as some of the other tools that we have access to, but it's very useful for visualizing. Now, what we can see in here is because the way I've organized my data, everything is within folders based off of the year and the month that the data was ordered, and then it's based on a file based off the day it was ordered. So I've got information within here, but maybe I want to access all the information within a file, or sorry, within a single folder. So if I, instead of getting this information right here, instead of looking at the customer ID, I want to look at all the information that's in each of the files in, we'll call it 2018 and January. I want all of the information in January. So I just removed the file name. And now up here, I have access to rows.filename. This is a really useful function that you have in Serverless Synapse because it shows where the data is coming from. So let me just show this. You can see I've got 30 files, or however many files are in here, and it is summing everything up based off the file that it came from. So we're querying multiple files at the exact same time. And all I've done is I've pointed the bulk operation to the folder that I want to do those queries on. So this is excellent. However, what if I want to do multiple folders and multiple files? Because you can see in this folder structure here, let's go into the sales. I've got order lines. I've got 4 different years here, and I've got all the months. And within there, I've got various dates. If I want to combine everything from all my folders and some things up that way, we need to start using other operations to do that. We could use a recursive structure, which instead of using this a specific path, I can just use 2 stars, and that's going to grab everything from every file that I've got access to. We're probably going to start seeing larger numbers because each of the months have the same file name, not necessarily the same folder name. So what I've got up there, I've got the rows, and I'm showing the file name. But if I show the rows.file path, probably need to aggregate that. Now it's going to give me a single record per file per folder. So we can traverse many folders in a recursive fashion. So you can see we're getting 2018. If I scroll down here enough, I'm going to get 2019, 2020, and 21. So you will see information like that. That just uses this double star mechanism. This still isn't the way I would generally recommend doing this type of thing. I'm a big fan of using wildcards if I know how the folder structure is supposed to look. So in this case, I know everything looks like, I want everything from, say, the 2018 year. And if I want to grab information from all my months and grab my days as well, I can start using wildcards. Wildcards are just the single star character that's in there. And if you use file path with a specific number in there, you get access to whichever wildcard is appearing in that order. So for example, wildcard number 1 refers to this first wildcard 1. File path number 2 refers to this right here. So I'll execute that, and you'll see that it actually parses out the individual months and days when I'm doing this type of operation. Even though my order lines have a file name that is the number orderlines.parquet, I can get that day from there. This does return it as a string. So again, being careful on your data types here. If you need to parse this out as, say, a date, I would go along the lines of actually explicitly converting it.
Just a quick question, Jared.
Yeah.
Sorry to interrupt.
No, go ahead.
Corey's asked how much data is in that data lake.
In this data lake, it's not very much. You'll see I've got 4 years worth of history, and I think these are daily files, although I had an issue when I was extracting this earlier today. So I've probably only got 50% of days for those 4 years covered. But each of the files are not very big, and actually when I go into best practices, I'm going to show, you'll see, each of these are 20 kilobytes ish. Yeah, maybe a couple hundred meg. I doubt there's a gig of data in here. However, the actual size of the files themselves is going to make things a little more efficient. One of the recommendations that Microsoft has is you should have your file sizes to the tune of 100 megabytes to 10 gigabytes ish. When it's a Parquet file or some of the other compressed types using, if you use Delta lakes, you might have some other conditions, but we, by and large, 100 meg to 200 or to 10 gig file size is what the Microsoft recommends you have in there. So yeah, the performance that I'm showing here is probably not too bad, and it's you can actually make these even more efficient than what I'm showing here. All right, and yeah, please feel free to interrupt me as we're going through this. So I definitely prefer to be interrupted over saving questions to the end, because otherwise it is talked out of context oftentimes. Okay, so we're talking about how we can extract various file paths from here. If we go back one more and actually do a conversion on that file path, let me extend this. You can see I've got the year as a wildcard, the month as a wildcard, the day as a wildcard, and then even here, I'm converting this as a specific partition date. So I can run that, and this will grab this is actually getting a lot of my data in here. We're traversing, 1,000 files or whatever, and it operates relatively quickly to do that. One of the things that you can do, though, if you're doing this type of analysis, is actually start adding some filters that are based off of these file paths. This is a really, really efficient way to do this type of querying. So for example, in here, if I want the file path where file path is 2018 and the month is 1, just adding that in there, and this will operate really, really quickly. So that's all about querying. How do you filter based off of where a file is within the data lake? Those are some of the best ways to go about this. I'm going to take this same kind of mechanism and show we can actually abstract a lot of this stuff away from the end user so that they don't have to type this just by using views. Views are a very, very useful way to do this type of thing. So all I've done here is I'm just selecting everything from those sales orders, and I've just included a couple pieces of metadata here. Don't use select star within your views. It's bad practice. So this is just going to create that view. But when we actually start using this, I want to show two things here. Each of those files has a column called order date. And my data is partitioned based off of order date. You may not have seen, I created a partition date in there based off the file paths. What can happen is if I use this order date, which is a column within those folders, this is going to run this query on top of everything that I've off of all the files that exist within in that view. If I wanted to make this a little more efficient, you can see this scanned 14 megabytes and moved 1 to do this type of operation. If instead of doing this based off of the order date, I did it based off the partition date, which would give me the exact same data, it's going to be significantly more efficient because now it's actually using the partition mechanisms. It scanned 1 megabyte and it moved 1. So partitioning your data using that those file paths is a good practice to be in. Last thing I want to do to demo here is that once we've actually done some stuff, I've got a query, I need that data, I want to do some further analysis on it, and I need to move it a little bit down the line as well. The best way or the most efficient way you can create tables and create data is actually by using CTAS statements, CETAS, I should say, create external table as select. In order to do that, we need to create a file format though. So let me just show what that ends up looking like. Again, all this is within the Microsoft documentation. So you guys, I'll grab the link to that in just a moment here and toss that in the chat. But you can see all we're doing is saying, I have a file format for Parquet, and it uses a specific type of data compression. Very simple. In that way, you don't really need to know a lot about the internals of what's going on there. Once I do that, I can create an external table. So this is going to be my sales orders CETAS, and I'm going to put this into my my data lake in a different folder. So you can see if I go to the top level, nothing exists other than my raw or my Synapse folders right now. But here I'm going to create everything. This is referring to that sales order view that I just created. If I run this, it's actually going to write a table for me that I can then use to do various queries. So let me go back to my data lake. I'm going to refresh my information. You'll see I'm going to get staging information, Wild World importers, sales, order lines, and then this is just all the Parquet overhead that happens when you create a external table. So you don't need to know the internals of this right now. All of that gets managed by the external table. A couple of problems with this is that even if I were to go down here and say drop external table, and let's just copy this over. Let's copy that and run that. So that ran without any issues. If I tried to recreate this, I'm going to run into a problem because that location already exists. So like I said, there's some limitations. If you need to go about recreating tables like this, you need to go back to your actual data lake, go in, I'm going to delete this stage folder, go through that process. And now I could say, I could recreate this if I need to. It'll run in just a moment there. And now I have access to that, that same folder structure. So like I said, you have to manage it, but using CE tasks is really efficient if you need to do other downstream analytical processes like ML or further data visualization. Let's just see, any other questions in there? Okay, I just want to quickly point out a couple of limitations here. So like I said, does not allow you to create, update, or delete records in any of the files or external tables. The data is as it is. It's completely, I shouldn't say it's completely static because you can use CE tasks, but it's static in that you can't change it once it's there. CE tasks only supports a couple of file types as well. So you can only have CE tasks on Parquet and CSV file types. So just very careful with that type of thing. You can't CE tasks for Delta Lake yet, although I believe that is a requested feature that's out there. And then you can't do it on like ORC files or anything like that. There are a couple best practices that are definitely recommended when you're provisioning something like this. Co-locate your storage account in the serverless workspace. So I've got both mine in Canada Central right now. That's going to be the best place, or you want them to be in the same place so that when you're querying things, that you're not paying for data movement all that much. When you have files in the Delta Lake or in the data lake, I highly recommend using Parquet or Delta files. You can, if you have other raw file types, CSVs, JSONs, other delimited files that you're using, use Spark jobs to convert and do the cleansing work, then query with serverless. You saw that I had partitioned my my data using different folders based off of some sort of date. You might not have the same sort of experience depending on your analytical workload or your integration workload, because you're likely moving data from based off of when something was last modified, or you're getting all the transactions that took place within the last time frame. So once you've got that, integrate those into a Delta file using Spark jobs. But I think we'll probably have another session on Spark jobs come the next user group. Like I said, keep file sizes between 100 meg and 10 gig, and then set some data types on your queries to improve performance. The last thing I will just demo here is if you have Power BI, I'm just going to go to my recent sources because I can go to, this is just my serverless endpoint. You can access that serverless database inherently. Here's my sales orders view. Here's the CE task. So this would actually be the external table that was created. I can query both of those and use Power BI in a really efficient way as well. So you can connect to the serverless instance using Power BI very easily.